Hello everyone, and welcome to the last video on finding the relationship between two quantities. And in this video we will talk about how to find the relationship between two quantities in a formula. Just as a reminder, the basic relationships were direct superposition. To identify them, you need to match your equation or formula against one of these, the standard form or the conservation form of the equation for direct superposition. If you have direct superposition as your relationship, then you can conclude that the values of the two quantities involved, those are Q2 and Q1, increase or decrease by the same amount. Keep in mind that K is constant. From the conservation form, we can say that the difference between the two values or the two quantities is constant. For inverse superposition, your equation should be similar to Q2 equals K minus Q1 or Q2 plus Q1 is equal to K. These are the standard form and the conservation form of the equation for inverse superposition. If you do have inverse superposition as your relationship, then you can conclude that an increase or decrease in the value of one of the quantities by a certain amount is matched by a decrease or increase in the value of the other quantity by the same amount. One increases, the other decreases, or one decreases, the other increases. And these increases and decreases are equal in size. From the conservation form, we can say that the sum of the two values, the values of the two quantities, is constant. For direct proportion, your equation should be similar to Q2 is equal to K times Q1, or the conservation form, Q2 divided by Q1 is equal to K. Again, K is a constant. If you do have direct proportion as your relationship, then you can conclude that the values of the two quantities get scaled by the same factor. It means they get multiplied by the same number, or they both get divided by the same number. From the conservation form, we can say that the quotient of the values of the two quantities is constant. For inverse proportion, your equation should be similar to either Q2 equals K over Q1, which is the standard form, or Q2 times Q1 is equal to K, which is the conservation form. If you do have inverse proportion as your relationship, then you can conclude that the value of one quantity is scaled by a factor, while the value of the other quantity is scaled by the inverse of that factor. So 1 gets multiplied by 2, 2 is your factor, the other gets multiplied by 1/2, which is the inverse of 2. We can also say from the conservation form that the product of the two values is constant. For linear relationships, your equation should be similar to Q2 equals B plus M Q1, with B and M being constants. Now, one way to find what kind of relationship you have is to try to find your constants first in the formula that's given to you. Once you have your constants, then you can see which equation it maps onto. Now, in order to find your constants, you can follow the following steps. First, you solve the formula for one of the quantities involved. Now, if you're very good and experienced with this kind of topic, then there are times when you find that you don't have to take step 1. You can just look at a formula and sort of tell. But these steps will always work. If you get stuck, you can always follow the steps and find out what kind of an equation or formula you have. To illustrate, let's take a look at a general problem where Q2 is equal to 3 brackets that multiply each other, and then plus we have a division here, and then minus the product of these two. This equation has been solved for Q2. So that's step number 1. It's already done. Then, on the right side of the equality, turn all the terms except the one with the unknown into a constant. If we take a look at what terms we have on the right side that do not have the constant, or do not have the quantity Q1, these are the term here and the term over here. And because the values in this term are constants, they are known numbers for a given problem, we can multiply it and we can work it out and get one number. We can do the same with this term. Because everything in this term is a constant, a known number, we can multiply them and finish it. And then we can take the value here and subtract the value here to come up with one number. And if we do that, our equation becomes b plus the term that had the unknown. Let's take a look again. These two together become b, and then we have plus the division over here. That's the first thing that you do. Turn as many terms, well, all the terms that don't have the unknown into a constant. Once you've done that, then you take a look at the term that has the unknown. Within this term, you turn all of the factors that do not have the unknown into a constant. So that would be these ones. We can take the factor at the top, divide by each of the factors down here, and come up with one number. That becomes m. The equation is linear. Now, the equation at the top turned into this form. Let's take a look once again at where b comes from and where m comes from. b corresponds to this term minus this term. Once these are turned into a constant, we take a look at the term that has the unknown in it. Now we take the factors within this term and turn those into a constant. Now, with this in mind, let's take a look at some problems. And here is a listing of all the different kinds of equations that we know about so far. For direct superposition, inverse superposition, direct proportion, and inverse proportion. The standard form of the equation and also the conservation form are given. For linear relationships, Q2 is equal to b plus mq1, with b and m being constants. Now, just a quick note that this equation can capture pretty much any linear relationship except vertical lines. And this is something that we will talk about in more detail in the videos ahead when we take up the topic of linear equations and talk about them in detail. Alright, problem number 1. What is the relationship between d and d0 in d equals d0 plus vt? So d and d0 are your q1 and q2. These are the two quantities that we want to relate. And as we said, we start with the terms that don't have the unknown and turn them into a constant. Note that the equation has been solved for Q2. And now on the right side, we have two terms. Vt does not have the unknown that we are looking at. That would be d0. And Vt turns into a constant. Okay, let's get rid of color coding. So this term becomes k. And of course you can rewrite this equation as k plus d0. This matches the standard form of the direct superposition problem. Q2 is equal to k plus q1. And therefore we have direct superposition. What this means is that if d0 increases by a certain amount, d will increase by the same amount. In an earlier video, I explained where this equation or formula comes from. d is the total distance that you cover, d0 is the initial distance, and vt is the distance that you cover because you're moving at some speed. If your initial distance increases by a certain amount, the total distance increases by the same amount. Problem number 2. Same formula, but this time we want to relate d and v, final distance and speed. We turn the terms that don't have the unknown into a constant. The unknowns are d and v, and therefore the term that turns into a constant this time is d0. Now within the term that has the unknown v, we take the factors that don't have the unknown and turn them into a constant. That's t. You can of course write m first, and this matches the form of a linear equation. Problem number 3. Identify the relationship between d and t in d equals d0 plus vt. You should actually pause the video and try this one yourself before you look at the solution. And for the solution, we turn the term that doesn't have t in it into a constant. And then, in this term that has the unknown t, we turn factors that don't have t in them into a constant. That would be v. And once again, we have a linear equation. So the relationship between d and t is linear. Problem number 4. Identify the relationship between d and v in this more general formula, d equals d0 plus vt plus 1/2 at squared. The final term takes care of the situation when you may speed up or slow down as you travel. We take the terms that don't have the unknown v and turn them into a constant. That would be d0 and 1/2 t squared. d0 plus 1/2 at squared turns into a constant. Now within the term that has the unknown v, we take the factors that don't have the unknown and turn them into a constant. That's t. Rewrite the equation, and we have a linear relationship. Now ideally all of this should happen in your head. None of these lines need to be written down. You can, in your head, you can imagine d0 plus 1/2 at squared, that's one constant, and then you add v times another constant. Try it. In time, unless you're able to do this in your head, the skill will not be as useful as you may think it is, although it's a skill. But it's most important that you should be able to take a look at this formula. For example, if you ask me what's the relationship between d and d0, I can say by very quickly looking at it that it's direct superposition because I turned all of this into a constant. Between d and v, linear. We just worked it out. Between d and a, it's linear. Between d and t, nonlinear, because t is going to the power of 2. Problem 5. Identify the relationship between m and m0 in the radiation formula. M equals 1/2 to the power of n times m0. In this problem, there is only one term. Within that term, we have two factors. 1/2 to the power of n is the first factor. m0 is the second factor. We take the factor that doesn't have m0 in it, that's 1/2 to the power of n, and turn it into a constant. And now we compare this to the equation, the standard form of the equation for direct proportion. Now we know that if we start with twice the mass, that's m0, we end up with twice as much, that's m. If we start with half the mass of a radioisotope, after the same length of time, this is constant and n keeps track of time, we end up with half as much m. Next problem, we have identified the relationship between m and n in m equals 1 over 2 to the power of n, m0. And here, again, we have one term on the right side. So there are no terms that turn into constants. Within this term, we have two factors. 1 over 2 to the power of n is factor number 1, and m0 is factor number 2. We turn the factor that doesn't have n in it into a constant. So we get 1 over 2 to the power of n times k. We can even combine k and the division by multiplying 1 over 2 to the power of n and k over 1 to end up with k over 2 to the power of n. Now this may deceptively look like the equation for inverse proportion, but it's not, because you're not dividing by n. You're not dividing by q1. q1 is n in this case. And these equations would have been the same if you had k over n, but you don't. This is not inverse proportion. In fact, it's none of the equations that we have in the chart over here, and it's not linear either. This equation, the relationship between m and n, is nonlinear. You should be able to say that if n is an exponent, or if n is a base. In all these cases, the relationship is nonlinear. You also notice that it does not make sense to say that a formula is linear or nonlinear or direct superposition or any of these, because the relationship depends on which two quantities you're trying to relate. In this formula, as we saw in problem number 5, the relationship between m and m0 is direct proportion. The relationship between m and n is nonlinear. Problem 7. Identify the relationship between P and V in PV equals nRT. Now, of course, we can solve this equation for one of the unknowns, let's say P, and we get P equals nRT over V. Now, here on the right side, there is only one term, and therefore there are no terms to turn into constants. In this term, there are three factors on the top, one factor down. Factors that do not have v in them turn into a constant. That would be nRT. And we end up with P equals k over v. Now this one is inverse proportion. Now, having said that, it is also possible to take a look at this formula without rearranging and solving it for P if we notice that to relate P and V, we turn nRT into a constant and we get PV equals K. This is the same as the conservation form of the inverse proportion relationship. Problem 8. Identify the relationship between E and M in the kinetic energy formula. E is equal to 1/2 mv squared. The equation has been solved for one of the unknowns. On the right hand side, we have only one term, and therefore there are no terms to turn into a constant. Within this term, there are three factors: 1/2, m, and v squared. We turn the ones that don't have m in them into a constant. That would be 1/2 times v squared. And this is the equation for direct proportion. So if something moves, it of course has some energy, kinetic energy. If something with twice the mass moves at the same speed, then it will have twice as much energy. 3 times the mass, 3 times the energy, and so on. Problem 9. For the same formula, identify the relationship between E and V. The equation or formula has been solved for one of the unknowns. On the right hand side, there is only one term. There are no terms that can be turned into a constant. Within this term, there are 3 factors, 1/2, m, and v squared. We turn the ones that don't have the unknown v in them into a constant. That would be 1/2 and m. Now this equation does not map onto any of the equations that we have here. This is not direct proportion, because for direct proportion the constant multiplies q1 only. q1 is v. Here the constant does not multiply v, it multiplies v squared. This equation is nonlinear. Problem 10. Identify the relationship between v and d1 in v equals d2 minus d1 divided by t2 minus t1. Now this is one of the challenging ones, and it takes a bit of practice to know what to do with this kind of a formula. Although once you learn how it works, then it becomes pretty easy to tell by just looking at it, especially because this kind of setup where you have the difference of one quantity on top and then you have the difference of another quantity down here is pretty common in basic formulas in physics. Now for this though, what you can do is you can take this equation and break the right side into 2 parts. This is like the reverse process for adding fractions. And you can even write the second term by putting d1 on the side, according to some of the rules that we talked about in earlier videos. And now I'll let you to argue your way through to the fact that the relationship between v and d1 is linear. Thank you very much for watching this video, and this is the end of the series for establishing relationships between quantities in formulas. The next set of videos will focus on linear equations. See you soon.